In this presentation, we will discuss the basic math concepts that you will need to know for this course. Please complete the problems that you will find in Appendix A. And the first thing we want to discuss is the addition and subtraction of the integer numbers. Then if we want to add two positive integer numbers, what we had to do is just we need to add the numbers, and the result will be had the common sign. The same thing we can do if we need to add the negative numbers. And if we add the negative numbers, we add the numbers and the results will be negative. Yes, the common sign. And let's solve the first three problems. And if we want to solve the problem number 1, 15 plus 23, just we add the numbers and the result will be positive. Yes, the result will be positive and will be 38. For the problem number 2, if we want to add negative 10 plus negative 12, and we know this is the same, we can rewrite this problem like minus 10 minus 12. It's the same thing. Then we add the numbers and the result is negative. The same for the problem number 3. We had negative 15 minus 2. We add the numbers and because both are negative, then the result must be negative. 17. If we want to add two integer numbers with unlike sign or with unlike signs, we had to subtract the numbers, and the result depends on the sign of the larger number. And again, if we want to add two integer numbers with unlike signs, we always need to subtract the numbers, and the sign of the result depends on the sign of the larger number. The sign of the result can be positive or can be negative, depending on the sign of the larger number. And let's solve this one. 12 minus 5, we subtract, will be 7. And because 12 is the larger number, then the result is positive. Minus 8 plus 3 will be 5, but 8 is the larger number, then the answer is negative. Minus 10 plus 25, we subtract the numbers, will be 15, but 25 is the larger number and it's positive, then the answer is positive. For multiplication and division, if we multiply numbers or we divide numbers and we divide integer numbers with the same sign, the answer is always positive. And if we multiply or divide integer numbers which had the same sign, the answer is always positive. But if we multiply or divide integer numbers which have opposite signs, the answer is always negative. Yes. And this rule applies for multiplication and for division. And if we multiply numbers with the same sign, the answer is positive. But if we multiply numbers with unlike signs, the answer is always negative. And let's try this few problems we had here. Then 6 times 7 is 42, because positive times positive is positive. Then negative times negative is positive. The answer is also 42. In this, we had to be careful. We had the combination of addition and multiplication. Yes, and first we need to eliminate the parentheses. This is minus 5. Negative times negative is positive 3. And now we can subtract the numbers because we had unlike signs. Minus 5 plus 3 will be 2. But 5 is the larger number, it's minus 2. And the same rule we can apply for division. Then 54 divided by 27, then the answer will be 2 and will be positive because both numbers are positive. Minus 9 minus 9 divided by negative 3, the answer will be positive 3 because negative divided by negative is positive. And in the second part we had unlike signs, and we know if we had unlike signs the answer is always negative. Then 16 times minus 3 will be negative 48. Negative 3.5 times 2 will be negative 7. 18 divided by negative 3 will be negative 6. Negative 15 divided by 3 will be negative 5. Now, how we can multiply fractions? Then to multiply fractions, we multiply the numerator with numerator and the denominator with the denominator. Then we multiply straight across like that. And we multiply 2 times 6 and 5 times 7. Then 2 times 6 is 12, 5 times 7 is 35. Once we have the answer, then we will check if we can reduce the fraction, or in some cases we can divide to get a decimal number. And in this, the same rule we apply when we multiply numbers is the same rule we need to apply when we multiply numbers along with units. And this is something you need to learn because we will multiply numbers along with units all the times when we are solving problems. And one example I want to write here is, for example, if you had 2 kilograms over cubic meter, let me write the cubic meter, times 3 cubic meters. And we will do exactly the same. Yes, we multiply numerator with numerator and denominator with the denominator. Then 2 times 3 is 6, and kilograms. As we multiply numerator with numerator is 6 kilograms cubic meters, and cubic meters times 1 will be cubic meters. Then yes, we can cancel out this, yes, and we have 6 kilograms. Probably later what you will do is you just cancel out here and you will see 2 times 3 is 6 kilograms. Yes, but right now let's try to complete all the steps. Then in some cases, as mentioned before, when we multiply the fractions, yes, we can reduce the fraction. Yes, like in this case, then we multiply numerator with numerator is 1 times 2 is 2, 4 times 3 is 12, and we can divide by 2, yes, then we will have 1 over 6. To divide fractions, what we had to do is we change the division by multiplication. Yes, we had 2/3 divided by 4 over 5. Then we just write the first fraction, change the division by multiplication, and just we multiply by the reciprocal of the second fraction, or by we flip the fraction. Yes, then we had 2/3 times 5 over 4. We flip the fraction. And now, because now we know how to multiply, just we say 2 times 5 is 10, yes, and 3 times 4 is 12. And if it's possible, we will reduce. We will divide by 2. We divide by 2. 10 divided by 2 is 5. 12 divided by 3 by 2 is 6. And this is important. And again, is we will apply, and I'm going to go with that right now, but we applied the same rule if we had numbers along with units. Yes, we will apply the same rule. The next thing I want to discuss quickly is the exponents. Remember, the exponent tell how many times we need to multiply the base. Yes, in this case, this is the base, will be 2. 3 is the exponent, and a is the result. Then 2 to the third power means 2 times 2 times 2. Yes, 3 is telling how many times we need to multiply 2. Then 2 to the third power equals to 8. Then let's solve quickly this few examples we had here. 5 to the second power will be 5 times 5 means 25. 4 to the third power will be 4 times 4 times 4 will be 4 times 4 is 16. 16 times 4 will be 64. 3 to the first power will be just 3. Yes, will be just 3. 5 times 4 to the second power. Here is important because we need to apply similar situation in different problems we had to solve. The only number is raised to the second power is 4. Yes, 5 is not inside the parentheses. Then what we had to do, we need to solve first what we had inside the parentheses. Then 4 to the second power. Now we know 4 to the second power is 4 times 4 means 16. 5 times 16 is 80. Now let's solve the last problem, is 100. And first we need to solve what we had in the numerator and what we had in the denominator. Then 2. Then we need to solve first what we had inside the parentheses, the exponent part. 5 to the second power equals to 25. Then let's solve what we had in the denominator. 2 times 25 is 50. Now we divide. 100 divided by 50 equals to 2. The same rule we apply if we had numbers is the same rule we apply if we had variables, and it's the same rule we apply if we had units. And if you had x to the second power means x times x. If you had y to the fifth power means y times y times y times y times y. If you had meters, let's think m is for meters. If you had meters times meter times meter, then you had cubic meters. Yes. If you had centimeters times centimeters means is square centimeters. Then these are units of volume and these are units for area. Yes. Then we apply the same rule we apply for numbers, the same rule we apply for variables and for units. Let's review some properties of the exponents. Then if we had the product of powers, what we had to do, we had to add the exponents. And let's write here one example. For example, if we had 10 to the second power, let's see if I can write a little better these numbers. And 10 to the second power times 10 to the third power, then we need to add the exponent. The one important thing is the base must be the same. Yes, in this case the base is 10, then the base must be the same. If the base is not the same, yes, if we had here 10 and here 5, we cannot apply these rules. Then 10, 2 plus 3, we add the, and it's 5. Again, here I am writing with all the steps, but here you can just write 10 to the second power times 10 to the third power is 10 to the fifth power. And let's try the number 2 is the division of 8 powers. Let's write this one a little better here. And now we had the division. Then let's write one example. Then we had 10 to the fifth power, 10 to the second power, and one important thing is we can apply this rule only if we had the same base. Yes, we had the same base. But then if we had division of 8 powers, what we had to do, we had to subtract the exponents. And it's 10 to the third power. Yes. And we know if we need to solve this, 10 to the third power is 1000. Yes, it's 1000. Then the next thing is power of 8 power. If we have power of 8 power, what we need to do is we need to multiply the exponents. Then, for example, if we had 2 to the third times to the second, and what we had to do is we need to multiply powers. Then 2, here is multiplication. 2 times 3 is 6. Then if we want to solve this one, 1, 2, let's write like that. 1, 2, 3, 4, 5, 6. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 34, is 32, 32 times 2 is 64. And the answer is 64. In power of 8 power, we need to multiply the exponents. This is one of the properties we need to apply in some of the problems we will solve when we start working on, when we start discussing motion and force. The second is the power of a product. If we have the power of a product, then we need to distribute the exponent for each of the terms. Yes. Then this we need to raise a to the n power and b, in this case b to the n power. And let's write one. Then we had two terms. For example, we had 2. This is one of the similar problems. We had to solve similar math in some of the problems. Let's write here to the second. Then here we need to raise to the second power both terms, 2 and 10 to the third power. Then in this case, what we had to do, because we know if we had power of a power, we need to multiply the exponents. And in this case, the exponent for 2 is 1. Yes, it's just 1. If there is no exponent, we know it's 1. And we try to write here 1. Then 2, 1 times 2 is 2 times 3. And here we had power of a power, then we need to multiply 3 times 2 is 6. Then 2 times 2 to the second power is 4. And we can write 10 to the power 6. Yes, we can just write like that. It's a larger number. Then we can write just like that. Now, if we had power of a quotient, then we had to do similar thing. We need to distribute the exponent to each term, to the numerator and the denominator. Then, for example, if we had 2/3 to the third power, then we can write this one like 2 to the third, third to the third. And 2 to the third power is 2 times 2 times 2 equals to 8. And 3 to the third power will be 3 times 3 is 9. 9 times 3 equals to 27. And this will be the answer. And the next thing we want to discuss is the zero exponent. And for the zero exponent, let's write first this one and then we will get some conclusion. Then let's think we had 5 to the second power divided by 5 to the second power. Then we can apply the division of a powers. Then we need to subtract the exponents. Then we write the base is 5. 2 minus 2 equals to 5 to the 0 power. Yes. Now let's solve this one using applying the math, the math concepts. And 5 to the second power is 25. 5 to the second power is 25. 25 divided by 25 equals to 1. But these two terms are the same thing. Yes, these are the same thing. Then if this equal to 5 to the 0 power, if this equal to 1, then the only thing we can conclude is 5 to the 0 power must be equal to 1. Yes, must be equal to 1. And we can just conclude that in general, any number to the 0 power equals to 1. Can be variable, can be an expression. Then any number or any expression of any variable to the 0 power equals always to 1. And x to the 0 equals 1, y to the 0 equals 1, 15 to the 0 power equals 1. And the next thing is the negative exponents. Then if we have the negative exponent, the way we can solve, we can get the results is just we need to convert this negative exponent into the positive. Then the only thing we had to do is just to rewrite this one as the reciprocal of the number and just change the sign of the exponent. For example, if we had a to the minus n power, then just write the reciprocal or flip the number. Yes, because here is that if you had over 1, just write the reciprocal and change the sign of this of the exponent. For example, if we had 5 to the minus 2 power, we can rewrite this one like 1 over 5 to the second power, and we know how to solve this one. And it's 1, 5 to the second power is 25. Then 5 to the minus 2 power is the same if we had 1 over 25. And if we want to write this one as a decimal, will be 0.04. And also, if the negative exponent is in the denominator, to convert this one, to change this one into a positive exponent, just you flip the fraction. As you move this one to top and change the sign. Yes, and change the sign. In other words, if we want to change the sign of the exponent, just flip the fraction. If the negative exponent is on top, move to the bottom. If the negative exponent is in the bottom, move to the top. Here we had one example, 1 over 3 to the negative 2 to the negative 2 power. Then to change this one into the positive, just move to the top, change the sign of the exponent. Then 3 to the second power is just 9. And here we had one more example. Yes, is 10 to the minus 3 is on top, move to the bottom, and change the sign. And we know 10 to the third power is 1000. This is why we had 10 to the negative 3 power equals to 1 over 1000. If we want to write this one as a decimal number, then will be 0.001. And this is one more example we had here, but here we had the subtraction, yes, 4 to the minus 1 power minus 5 to the minus 1 power also. Then we cannot solve if the numbers have negative power. Then we need to change the sign of the exponent to solve. Then to do that, we will apply the rule we already learned. Then 4 to the minus 1. To change this one, just move to the bottom. Then it will be 1. Let me write here. It will be 1. 1 over. But really, we know 4 to the first power is just 4. Yes, then we really don't. Oh, let's keep this one. Then it's the same as 1 over 4 minus 1 over 5. Now we need to solve this expression. Then we need to know how to add fractions. To add fractions or to subtract fractions, we need common denominator. Then we need to find the LCD, or the least common denominator. The least common denominator of 4 and 5 is 20. Then we want 20 as the denominator. To do that, we need to multiply the first fraction by 5. And we need to multiply the second fraction by 4. Here is multiplication. 5 times 5 is 5. 5 times 4 is 20. 4 times 1 is 4. 4 times 5 is 20. Now we had common denominator. Just we need to, in this case, subtract the numerators, and keep the denominator. Then 5, let's write all the steps. 5 minus 4 over 20 will be 1 over 20. Then this equals to 1 over 20. That's the answer. To combine like terms, we need to just to remember we can combine like terms only if they have the same exponents and the same base. Yes, only if we have the same exponents and the same base. Then to combine like terms, we can add or subtract the coefficients. The coefficients are the numbers in front of the variables. Yes, for example, here the coefficient for x to the third is 3. And we can keep the common variable. We can keep the common variable if the terms are if the terms we want to combine are like terms. If they are not like terms, we cannot combine them. And the same rule applies when we want to add numbers along with the units. We can add only numbers if they have the same units. Then, for example, can we add these two terms? Are they like? Then the answer is no, because the base is different. Yes, the base is different. Then we cannot add this, we cannot combine these terms because the base is different. Even they had the same exponent, but the base is different. We had x and we had y here. What about this one? We had the same base, but the exponents are different. Then we cannot combine different exponents. Can we combine these two terms? The answer is yes, because we had x to the second, same base, same exponents. Then x to the second, if we had 1x to the second plus 1x to the second, and finally we had 2x to the second. Can we combine these two terms? The answer is yes, we can combine, because we had the same variable and the same exponent. Yes, it's 5. Then 3p to the 5 minus 7p to the 5 will be 3 minus 7 is negative 4p to the 5. We subtract the numbers and we keep the common variables. And it's minus 4p to the 5. Then this is the same thing if we had numbers along with the units. For example, if we had 5 kilograms, the only we can add this if we had the same unit, we can add these two terms. And 5 kilograms plus 2 kilograms is 7 kilograms. Then can we add, for example, 2 grams plus 7 kilograms? The answer is no, because we don't have the same unit. Yes, it's similar concept. Yes, the units must be like. Yes, then in this case we need to do something. We cannot add these two numbers together. For example, if we had 3 plus 5, if we had 3 meter squared plus 5 meter squares, then we can add this number, yes, because we have the same unit. Yes, the units are exactly the same, and it's 8. What about this one? 10. Can we combine these two? The answer is no, because the units are not the same. And it's similar concept we apply when we are doing some math with the when we had numbers along with the units. And now we want to practice. We want to multiply and divide some expression that involve variable and exponents and numbers. And what we will do is we will apply what we already learned. Yes, and remember, we can in multiplications, what we had to do, if we had the same base, we can add the exponents. And in division, if we had the same base, we can subtract the exponents. Then let's try to solve this problem. Then if we had this problem, what we had to do is we need to multiply the numbers first. 3 times 5, sorry. It's 3 times 5 times x. And here I am doing with all the, I am solving with all the steps, but you can skip some steps if you want. Then 3 times 5 is 15. X to the second times x, same base, x, we add 2 plus 1 equals 3. Y is the same base, 3 plus 4 is 7. Then the answer is 15, x to the third, y to the 7. Here we can do the same thing, but here we have to apply the division rule. Then 16 divided by 2, we divide the numbers, and we apply the rule for the exponents, the division of the powers, and f x to 12, this is 5. And 16 divided by 2 is 8, here is 5 minus 12, then we will add a x. 5 minus 12, we know it's negative because 12 is the larger number, 7. Then this is one possible answer, and also it is right. Yes, if you, some cases, if you don't want the negative exponent, remember to change the sign. Just you move, if it's on the top, we move to the bottom. And these two answers are the same and both are correct. Okay. And the answer can be this one or this one. Then let's try this. We want to multiply and divide, or divide this to this expression. Then let's try to solve. Yes? And I want to solve in two different ways, and you just solve in the way you is better for you. Then, and I will write here with all the steps. And let's solve in the first way. Then we will apply the rule for the division. Then 15 over 3. Let me write this one. X to the third, x to the negative third, y minus 1, y to the, and 15 divided by 3 is 5. Here we had the same base. Remember, is the top exponent minus the bottom exponent. Then will be 3, and we have to be careful because this is negative. 3 minus 3. Then we had double negative here. Yes, we had to be careful with that. It's minus 1, minus 5. Minus 1, minus 5. Then negative times negative is positive. Really, we had to add here. Then is 5. 3 plus 3 is 6. Y minus 1 minus 5. We need to add the numbers. Both are negative, and the answer is negative. And this is what one possible answer, and the other possible answer will be. This is negative. We can write like that. Yes. If it's negative, yes, we move to the bottom. And this can be the two. Both answers are correct. Then let's now apply using the negative exponent property. And remember, we can divide the numbers. This is 15 over 3. Now, if this is negative, what to do? We can move to the top, yes, and then we will change the sign. This is negative, move to the top, and will be 3. Yes, you had y. This is positive. If we move to the top, will be negative 5. Yes, we move this one to the top, will be positive. Just we change the sign. Yes. Then 15 divided by 3 is 5. Now we have the same base, x. We add the exponents. 3 plus 3 is 6. Y, negative 1 plus negative 5 is negative 6. And we can rewrite this one like that. Yes. And both answers. And you can solve either in this way, in the first way, or the second way. Both ways are correct. Is the way you prefer. And this is all I had to discuss in this part. The last topic I would like to review is the solving linear equations. And first we want to discuss how we can solve one-step equations. And for one-step equation, just we need to apply is just one operation. And for example, if we want to solve the first equation, we want to solve for x, and we need to subtract 5 on both sides of the equation. Let's cancel out, and you have x. 7 minus 5 will be 2. X equals 2. Just one step. Yes. Then if we had x minus 22 equal to 36, what we had to do to solve for x, to get x by itself, we need to add 22 on both sides. Then this, we had x. Here, yes, we need to add the numbers, then will be 58. And the x value in this case will be 58, just one step. In this case, 5 is multiplying x. And in order to solve for x, we need to divide by 5. Always the opposite operation. And divide by 5. And 5 divided by 5 is 1. This is why we cancel out. And x equal 30 divided by 5 is 6. Then x equal 6. For the last one, then there are two ways we can solve this one, and I will solve in both ways, and you will choose the way is easy for you. Then let me write again the question here: x over 4 equal to -5. And because we need to solve for x and 4 is divine, then we need to multiply by 4 on both sides of the equation. Then we multiply by 4 here, and we multiply by 4 here. Then 4 divided by 4 is 1. We can simplify. And -5 times 4 is -20. And let me here, we can solve in another way. Let's try to. Then let's write again here x over 4 equal to -5. Then the other way we can solve this one, if we had just one term, one fraction as 1/3 on one side and one term on the other side, we can use the cross product. The cross product is we need to multiply these two terms. And x times 1 equals x. 4 times -5, right here, and x equal to -20. And remember, cross product, we multiply cross, yes, x times 1 equal x, 4 times -5 equals to -20. And either way, you will get the same answer, and both ways are correct. Now we will review how we can solve two-step equation. For two-step equation, remember the step number 1 is add or subtract always, and the step number 2 is multiply or divide. And let's start solving the problem, the first problem. Then 3x minus 4 equals to 11. Then to solve this equation, first we need to add 4. As we want to get x by itself, then first we need to add 4 on both sides of the equation. Then we will have 3x. This cancel out, equals to 11 plus 4 will be 15. Then we divide by 3, x equals to 5. For the next problem, we want to solve for m. Then first we need to subtract 2. Remember, this is the first step, yes. Then we need to subtract, and we will negative 5m. This cancel out. 27 minus 2 equals to 25. Then we divide by -5, divide by -5, and then we had here 25 divided by -5 is -5. For the next step, for the next problem, problem number 3, in this case we had the variable, which is t, we had the variable on both sides of the equation. Then the first thing we want to do is we want to get the variable just on one side of the equation. And because we had here plus t, then we need to subtract t on both sides. T minus t is 0, or we can say it's cancel out. Then on this side we have -4, and on this side we have 2t minus 1t is just t, or 1t is the same thing, plus 5. To solve for t, we subtract 5 on both sides. Then this cancel out. -4 plus -5 is -9. And as both are negative, we add the numbers together, and the answer is negative. then t equals to negative 9. Negative 9. For the third problem, here the variable is in the denominator, then we have to be careful with that. But the first step is always add or subtract. Then we need to subtract 3 first. Then 5 over x. Let's cancel out 2 minus 3, negative 1. If the variable is in the denominator, what I suggest you is always solve the problem using cross product. Just be careful, you can use cross product only if you had one term on this side and one term on the other side. And let me write this one a little better. Let me write here 5 over x. Then let's use cross product, and if the variable is in the denominator, this is the best option. Use cross product. Then we know negative 1 over 1 is the same as negative 1. Then 5 times 1 equals to minus x, or minus 1 times x. But 5 times 1 is 5. Yes, we had 5. I will write here 5. 1x, but we want to solve for x, then we need to divide by negative 1 on both sides. 5 divided by negative 1 is negative 5 equals x. And you can skip steps. Here I am writing all the steps, but you don't need to. Yes, you don't need to. Then, for example, we can just say 5 times 1 is 5. Minus 1x is equals to negative 1x. Then just divide by negative 1 on both sides and get this. In the last equations we want to solve is in equation which we had variables. Yes? Instead of numbers, we had just variables. Yes, just letters. Then in this case, we will solve in the same way we solved equation in which we had numbers and variables. Then what we can do is we can think some of the variables are numbers. For example, in the first equation, we need to solve for hf. Yes, we need to solve for this variable for hf. Then in this equation, and the same thing we had to do in this equation. And let's try to solve the first one. If we want to solve for h, we need to divide by 5. This is 1, then 15 divided by 5 equals to 3. And the h value equals to 3. Then because we will need to solve for hf, we can think q and n in this equation are numbers, and we can do the same thing we did for the first equation. Then if we need to solve for h, what we can do is we divide by, in this case we divide by 5, we divide by m on both sides in this case. Then this cancel out in the same way we did for the first. Because these are unlike terms, we can now combine. These are just variables. We can write q over m. And this is the answer. Let's try the number 2. In this case, the variable is in the denominator, is this b. Then what to do with the variables in the denominator? Remember, just we can solve using the cross product. It's easy. Then just 1. Then 5 times 3. Let's write is 5 times 3 is 15v. 1 times 2. What times 2 will be 2. Because we want to solve for v, we need to divide by 15. 2 over, and this is the answer. This is 15. Let me write again. 15. And we can do the same, we can follow the same procedure to solve the second problem. Yes, we can think else we had L over 1, and we can use the cross product, yes, to solve the problem. Let me write here better this cross product like that. And L times N times V equals to 1 times H is just H. But we need to solve for V. Yes, the V is the variable. Then we can think the other two just are numbers. Then we divide by, this cancel out, and we have V equal to H over. This is the answer. And it's the same thing. Yes, we did it. We don't need to do anything different. If we had numbers and we had variables, we had to follow the same procedure. And now we want to solve for V1. Always, if you had one term on this side, like in this case, and one term on this side, always I suggest you to solve the equation using the cross product. Is easy. And we need to solve for V1. The others we can think are numbers. And we will have V1 T2 equals to P2 T1. Now we need to solve for V1. Then the other are numbers. We need to solve for V1. Then what we had to do is we need to divide by V1, because we want to solve for this variable. This is the variable we want to solve. And we need to get this variable by itself. Then if we divide by P1 T2, we had to do the same on the other side. This cancel out, and we have V1 1 over this is the answer. And this is all we are going to discuss in this presentation.